Yeah, hello and welcome back to the mobile application development program with Flutter. And today we'll be looking at introduction to that. As I said, we'll be covering the basics of that, which is going to give you a kind of kickstart as a beginner in this course. But it's very important that you keep learning that programming language. You could decide to enroll for, a full application development course in the proposed platform, which I said that Kim Plus is capable of doing that for you. And so let's just dive right in. So the introduction to that. So we're going to be learning about that and what is that, which I explained in the previous video. That is an object-oriented programming language, and it does so many wonderful features that it compiles in JWT, and you understand. So if you've gone through my previous video, you'd see me going through all of that. So we're going to be doing some basics of that. Now, I introduce you to the IDE we're going to be using, which is the DATPad. And this is the DATPad. When you go to datpad.dev, you're going to get this IDE. For those of us who are going to be using our VS Code, which I explained in the previous videos, if you don't want to use the internet and you've installed Flutter on your system, you can just open your VS Code. So let me just go through that. So anyone should be fine. So you just go to the documents, kind of create a file like my dat class here that I have here, which I have one file here. So I'm going to open this with VS Code. So as you can see, I said it before, if you have Flutter installed, if you follow the installation of Flutter, you shouldn't have any issue running your DAT because Flutter ships in with both DAT and Flutter itself. So you're going to create a new file, hello world.dat, and the same thing we're going to be doing on the IDE is the same thing we're going to be doing here. The only difference with the IDE, which is you have to, click on run. When you have to run all of these, you don't have to start typing on the terminal. But for that here, you have to open the terminal by the second icon on top, which is going to bring out your terminal. And you want to make sure that you select your bash. Anyone is fine, but I prefer to use bash since we have git bash installed. So wait for the terminal to come up, and we're going to use the command which says dat and the name of the file that you need to use to operate it, to create it. So waiting for my terminal to come up. I'll just try to create one more terminal here. Okay. So as I said, let me kill this one. So the command is dat. So whenever you want to run your code, you have to just type in dat and the name of your file, which is hello.dat there. So once you click enter, that should spin up whatever code you're writing. So I'll be working basically on my IDE online. So I'll just drag this on down. So this is where I'm going to write my code. This is the console. Then if there's any error for documentation and the rest, you're going to have them in here. So your notepad, like your editor, your console, this is going to show the results, and this is where it's going to show you some kind of documentations. If there's any error, maybe you didn't remember to close something, and you can see the document, some error line, blah, and so on. So I'm going to clear all of these. I'm going to clear all of this, and I'm going to explain what that code is. Now, immediately as you click run on the code, there is a function, and let me explain what functions are. Functions are piece of codes. They don't run except you call them. Now, there's a particular function you'll be working with in that, which is called the main function. So let me void main. Yes. So let me explain what this is happening. Now, the meaning of void means this function is not going to return anything. I'm going to explain that in a later video. Void means nothing, like you're not returning anything. So if I come in here and say int means number, I'm trying to say return number, but we can't do that for a main function. So this is the main function. So immediately as you click on run, what that does is that it goes inside the code and look for that particular function that is called main. So this is how to create a function. So, but you can't use this main twice. So it is reserved, and all your codes are going to be inside here, codes that you want them to spin up when you hit the run button. So let me say I come in here and I have print. Now print is also a function, but it has been created already. Like it has been made down. It is inbuilt function. It is an inbuilt function. And inbuilt functions are functions that comes in shipped out of the box by that programming language. So there's a function called print, and it has this bracket. Whenever you see anything that has this bracket beside it, just imagine it as a function. It takes in something and it wants to do something. So it's just like telling someone to do something. You write a kind of instruction in a paper and you give it to the person. Just imagine that paper as a function because it takes some instruction. So this void main is a function, and these curly braces. So there are three types of the brackets you're going to work in is the normal brackets. There are these ones, the curly braces, and these square brackets. So just have it in the back of your mind. I think those are the three most important brackets. Sure, that's the three brackets we have on our keyboards right now. So that's the side. So now these curly braces denotes that anything you write inside here belongs to that function. So it's just like having a sheet of paper here. Imagine this is a function. This sheet of paper is a function here. So this is like the void main. Now whatever is written inside this paper is what is belonging to that particular paper or function. So whatever code, whatever you tell the computer to do inside this function here, it's what the computer is going to run. So I'm taking my time to run a kind of explanation on that. So let's do something. So the first instruction we're going to give the computer is the print. So I said before that in small letters, please, print, then let me say hello world. Then do not forget to put the semicolon at the end. The semicolon in that means I'm done with that line of code and I want to do something else, or that's all. So the semicolon is important. If you don't put it, you get the computer, you're going to get that angry. As you can see, it says expected to find a semicolon at the end. So your code is incomplete and it's giving you red. So definitely I want to put the semicolon here. Then immediately as I run it, you can see we're going to have hello world printed on the screen. So if I come in here and I place this one outside and I run this, so it's not going to actually work. So it won't work here. So it's preferable to put it in here, then run it now. It's going to work. So I wanted to run an explanation on that, which I'm going to do in a later video to explain to you how this main function is. So if I come in here and I have some kind of instruction hop here, they are not going to run except you put them inside they wouldn't run except you call them inside the main function, which you are still going to see as video goes on. So back to our tutorial guide. As you can see, every app requires the top level main function. Every application requires the top level main function. So every app you're going to build must have that one main function. You're going to see it in Flutter when we start working, where execution starts. So if that cannot find a main function, then there is no app to run. Functions that don't explicitly return a value have the void return type. I'm going to explain the return type for you in a later video. Now, to display text on the console, you can use the top level print function. As you can see, it's a top level print function. Void main, then we did this particular stuff. So you can print as many things as you want. So in the next video, we're going to be talking about data types. I'm going to pick in two for now. And why I'm going to be explaining the data types is so that you can understand what variables are and what the print function is doing. Now, what are data types? Most of us have been to when we were small, and you've noticed that we start going to school and they start teaching us ABC or 1, 2, 3. They won't tell you that that is a data type, and that's because you are learning a language, be it English, be it whatever language, Yoruba, Hausa, French. Every language works the same. It cuts across the same principle. They'll teach you how to, how to write ABC in that language. They're going to teach you how to write 1, 2, 3 in that language. Now, there are two data types I'm going to start with initially, which is the string and which is the integer. So before we go into variable, now how do we write ABC in programming language, in any programming language, or in that? Now you can see we have print hello world. Now what makes the computer print this hello world to the screen? And that's because of this quotation or parentheses, this double quotation that is wrapping the text. Now if I come in here and I write hello world, it's kind of confusing because the computer doesn't understand what is happening. It's just seeing some bunches of, or some bunch of letters, HELL, some space, then word. And the computer doesn't understand any of these. So the best way to tell the computer that you just want to print characters, strings, letters, alphabet, it is needed for you to enclose it or wrap it in a double quotation. So when you do that, the computer understands that, okay, you actually want to just print what is written in there. So I can run it now, and you're going to have hello world. Now, another data type, so I'm talking about strings now, which I'm still going to explain to you very well. Now, another data type we can have is numbers. So like 5. So once you want to write numbers, because numbers are computer understands number out of the box, and there is no need for you to start enclosing it in parentheses or double quotation. So some people are going to ask, can I use single and double? Yes, you can use single, you could use double. But once you start with single, make sure you end it with single. Once you start with double, end it with double. You can start with double and put in Victor, and start with end it with double quotation. That is not actually going to work. So right here, if you start with double, make sure you end it with double. And this is the best way to do it. So once I run this, the computer is going to print Victor from me. So I was talking about numbers. So if I come in and put in 5 here, and I run it, you'd see we're going to have 5 printed out to the screen. So yeah, so that is integers for you. Now we don't need to enclose integers in we don't need to enclose encapsulate integers in quotation, which is not going to, it doesn't mean anything. You could do it, as you can see. Let's try it. And I run it now. I'm still going to get that particular 5. But there is a difference between this kind of data. Now, this data is just printing an ordinary 5. It cannot perform arithmetic operations. Now, let me give you an example. If I come in here and I say 5 plus 5, and I run it now, what do we get? 55. Now, the plus is actually going to do what? Take this 5 and take this 5 and just join them together, and which is not what we want arithmetically. So, and it is only plus that would even work. If you try this with minus, you're going to get an error. So once we run this, we're going to get an error. It says the operator minus isn't defined for the type string. So it's not going to work. So plus, we only just join them because it has this power of concatenation. So concatenation means taking what's on the left, taking what's on the right, and just putting it together to give you something. So you wouldn't want to, work with that. So, but if you want to perform arithmetic equations with numbers, it is preferable for you to just write them out without double quotation. There is no need adding quotation. With this, you can perform arithmetic equations like this. So I'm just going to check some things out of my list because I'm following a particular list. So I'm going to check that I've talked about. So we've talked about strings. They are all called data types. So data types. So we've talked about strings. We've talked about integers. And it is important why I'm telling you how they look, because when we start working with them in variables, you would understand what it means. So let's go and let's jump into the next one. So back here, we're talking about variables. So what are variables? Even in type-safe Dart code, you can declare most variables without explicitly specifying their type using var. Thanks to the type inference, these variables types are determined by their initial value. Now, what are variables? Imagine variables like container. Imagine you have a very long name and you don't want to have to repeat yourself. You want somewhere whereby you can store this name and call this name later. So let me give you an example of that. Maybe I have a name called Victor, and it includes my first and my last name, and I want to print this, 5 times, and I don't want to have to start typing this name because it's too long. I can decide to store them inside a variable. Now, there are various ways to create a variable. As I said, imagine it as a container that is going to have a name, and you're going to put something inside. So let's say I want to create a variable called my name. You can use any word of your choice, but not reserved words. Reserved words in Python, reserved words in Dart are words that belongs or words that the programming language is using and you can't use. That's a reserved word. E.g. are like print. You can't use this word for anything. You can't use it to create a variable or whatsoever. So now let's create a variable in Dart. Now there are various ways to create a variable. Now the first way to create a variable is by using the var. Now this var is like you're trying to tell the computer you want to create a variable, and any data type can enter inside that variable. So let me say var username is equals to Victor. So now what I just did was that I created a container, a variable, which is like a location on the computer memory called username, and I'm storing the value called Victor inside it. So this is a variable, this is a container, which is pointing to this value. So this is like taking a kind of plate or a cover plate, and you're putting something inside that plate. So whenever you reference that plate, you're going to get the value inside. So here I can come here and I print username, and what I'm going to get is going to be Victor. So instead of printing Victor, I am printing the username, which has Victor stored inside it. So I can decide to say another one, var num1 equals to 10. So I said my number 1 is 10. So once I come down here to print num1, do not forget to always put the semicolon at the end, which is very important. And I run it, I'm going to get the Victor, and I'm going to get another number under it. So can you see I'm having Victor here and I'm having 10 here. So that is using var. Now, what is the advantage of this var and the disadvantage? Now, the advantage of using var is that you can change the kind of value that is inside that inside the particular data variable. So let's say here username is Victor or was Victor. I can change it later by saying username is equals to Dio. So once I run this now, it's going to change, and I can also say username is equals to 33. And once I run this now, okay, you see we're going to have an error. So now with the var becomes what the data type is. Now, when we created the username, we put in a string inside the variable. We put in a string. This is a string. Now, the computer has registered this username as a string. Now, I'm coming in to put in a number, which is giving me a kind of compilation error. As you can see, a value of type int can't be assigned to a variable of type string. Now you see that we tried putting another value inside of Dio and it went. Now we're trying to put in 33, it's not working. And that's because the first thing you put inside that container becomes the kind of data that should be inside the container. So we'll put in a string, a character. It will not take a number later. That is one thing about var. It will not want to take in. So if I had come in here, so let me try another one, var, and let me say I put in num1 is equals to 45. Let's print num1 now. So let's try. You can see we're going to get in 45. Let me just run this. We're going to get 45. Now, if I come down here, I say num1 is equals to Dio now, then that's me changing the data type. You can see now we're having an error which says a value of type string can't be assigned to a variable of type int. It says the container, the initial data of the container was a number. Why do you want to put a string inside, which is not going to work? So once you start with a number, you have to keep using a number, and that's one thing about var. So if I come in here and I put in what was it called? Let's say 56 now, and I run it, I'm going to get 56. And why I'm explaining this thing is so that you can understand these concepts of what is going on. So, and that is var. Now, the next thing I want to talk about is initialization and declaration. Initialization is like creating a variable and, without giving it a value. Then declaration is actually declaring the value once you create the variable. So I'm going to come again. We have declaration, we have initialization. Now, declaration is like you're creating a variable and you don't know what the value is going to be, but you want to put in something later. So if I come in here, maybe I have, I want to create a variable called var, username, which is, I don't want to put anything inside here. I can make sure I just put in this semicolon. So this doesn't have any value, it doesn't have any value, as you can see. But when I'm going to come in here, I'm going to say username. So if I have the value later, maybe later in the code, if I have the value, I don't need to put in the var again. Because once you've used var to create a variable, once you want to change the value or you want to assign something to the variable, you don't need to put in the var. The var is done once, and you put in your value next. So I can say username is equals to Dio. Make sure to close this. I come in here and I print username. So this is like initializing. Then I assign something to it, and I can print it out. So once I run it, we have Dio. So this is initialization. Now, declaration is like when you call in the var, the username. We did this before, and we'll give it a name. So this is like the declaration. So immediately as we're creating the variable, we're giving it the value, and that's declaration. So now I can just print in the username, so like this, and we have these. So that's for var. Now the next way to create a variable is by using dynamic. So instead of var, you can use dynamic. Now the difference between dynamic and var is that in dynamic, it can change at any point. If you start with string, you can end with int. So let me say dynamic username is equals to Victor, like this. I can change the username to be equals to 56, and I can print the username. Now, unlike var, once you start with string, you cannot change it to integer. But with dynamic, as the word says, dynamic, if you like, you start with string, you can change it to integer. If you start with integer, you can change it to string. That is dynamic for you. The values, the data types can change. But once it comes to var, whatever you start with is what is going to follow along throughout the lifespan of the application. That is var for you. Now, if you want to become more explicit, you want to be very, very explicit. You don't want to use dynamic. You don't want to use var. You can use what we call the actual data type you want. So I can specify in capital letters string username is equals to Victor. So this means difference between this guy and var and dynamic is that once you use string, the first thing you have to put inside there must actually be a string. Nothing like first in and we keep using it. If you put in string username, the username must actually take a string, a character. So here I'm going to print username like this. Then I'm going to run this. And you can see we have Victor. So if I even come in here right from the start and I try to put 76, we're going to have an error. It says a value of int can't be assigned to a value of string. So there's nothing like first come, first serve. If you said string, you have to put string. So that's for string. For integer, you use the int. So it's only integer we use. Integer and boolean we use small letter. I'm going to come to boolean, but I said I wanted to take string and integer first. So for the integer, we're going to have int num1 is equals to 56. So like this. So it's I can print in num1. Don't forget to always close the semicolon. And once you do this, you have the 56. And that's how it works when it comes to creating a variable. So if we slide back inside here, you can see various ways they created a variable. The var name is equals to yoga. Var here is 1997, and it's changing. We have double. You can see we have doubles, and so on. So we're still going to be coming to all of these soon. So just to show you the basics. So let's go to the syntax basics. So let's look at variables. And as you can see, this is initializing the variable. Var name is equals to Bob. Now, or you can use the object name. Now, variable stores reference. The variable called names contains a reference to a string. So you could read through this. So if you go to that.dev/language, now you can see we said string equals. Now you can explicitly declare the type that you want that would be inferred. So once you say string, nothing apart from string should be inside this. So we're going to be talking about null safety. What is null safety, or what are null safety? When you specify, because null in that, it's a data type. So what is null? Null is like nothing. There is nothing inside. So there is something called null. So null means empty. So when you specify a type of variable, parameter, or another relevant component, you can control whether the type allows null. So to enable null, you have to put in the question mark, which I'm going to explain to you now. So if I come in here, because that likes you to handle null issues. Null means nothing, and it can cause a very big problem in your application. So let's talk about the initializing, where I said string username. Now, maybe I don't want to put anything here like this. I don't want to put anything inside it. Now, this username is null. So let's try and print it. Now we have an error. The error says the non-nullable local variable username must be assigned before it can be used. Now that is telling that this thing is null. Please assign it. It's going to cause an issue. But if you don't want to put anything inside and you want that to, allow it, you can tell that by putting a question mark here. Now this question mark means it could be null. It means it could be empty. I might not put anything inside till the end of the program. So once I run this now, the error goes away and we're going to be having null. So once I print username, we'll have it null. But if you don't put the question mark, that will be taking extra security steps to make sure that you know what you are doing. So me putting question mark in front of the inferred data type, the object itself, it tells you that, okay, fine, this thing is going to be null. But if you're not going to put it, that expects you to, at some point, put something inside. So something like this. Then once I run it, you can see we have emitter and without any error. So that is how to handle null. Anything, it could be null. So there are still more ways to handle null. So it's called null safety. So there are various ways to handle it, which we're just looking at the first one. So as you can see, int question mark line count. So it's possible that the line count should be null. So we have another one called late. Now, late is, how am I going to put it? It's a kind of variable that it tells you that it's going to come, but it might be late. So it's going to come actually, but it's going to take a lot of time, but it's actually going to come. So we could use late. Now, late modifier has two use cases: declaring a non-nullable variable that initializes after its declaration, lazily initializing a variable. So often that controls flow analysis can detect when a nullable variable is set to non-null value before it's being used. So it might look complex to you, but it's going to take time understanding most of these things. But as I said, we're just going into the basics of that and understanding what is going on. So we have now final and const. Now, if we intend to change a variable, if you never intend to change a variable, use final or const, either instead of var or in addition to a type. Final variable can be set only once. A const variable is a compile time constant. Const variables are implicitly final. So there is a difference between the both of them. So I'm going to explain what that means in my code. So I'm going to be using const or final for the matter. So if I come in here and I say final int name is equals to num1 is equals to 5. So what I'm trying to say is that if I come in here and say num1 is equals to 2, I'm going to get an error. Now the error says the final variable num1 can only be set once. So it's either you know the value once, it doesn't change, it cannot change. You set it once, you cannot change the value again. The same thing with const. So once you come in here and you use const, so it's good for some kind of security issues. Maybe you want to set something in your application that should not change. You could use the const or the final. You could see when we were using the var and the dynamic and the normal ones, it was changing. So see the way we created it. Now we can put in, attach the const, then the kind of value you want, then the num1. If you don't want it like that, you can decide to say const num1 is equals to 5. Then we can print num1. And when I run it, You can see we have in 5 here. So that is like the constant. So that 5 shouldn't change and it would not change. So that is for const and that's for final. So the both have differences which we're going to be checking later in the video, but just for you to understand this simple basic. Now there's another data type called bool is male. Now this is just a variable I'm creating and I can say is equals to true. Now boolean is true or false, which means 1 or 0. Boolean is true or false, which is like saying 1 or 0, if you understand what I'm trying to say. So once I print is male, so once I run this, you are going to see true. Once I make it false, run this, you're going to see false. So when you hear the word boolean, bool means true or false. So it's like saying yes or no. So the computer looks at it as 1 and 0. 1 is like saying on, off, and 0 is like saying off. Which brings us to the next thing, which is if and else. So conditions. So there's something called conditions in that if and else. So let's say how do we going to write a condition? Now let me have a bool is male is equals to true. Now I could write a condition by saying if, then I want to open this bracket. Now this bracket is going to take what you want to check. Condition is like telling someone, if you go to the market, if there is rice. If you go to the market and if there is rice, the condition is when you get to the market and there is rice, what are you supposed to do? So now, if is male is equals to true. Now, what is the meaning of this is equals to, which I'm going to be doing in the next video when I'm going to be explaining all of this. So, let me break this down. So as I said earlier, as you can see, this is now a typical condition. If this is going to evaluate to true, so if the computer checks it that is male is equals to true. So this is like saying is male equals to true. The computer is going to come up here and say, okay, yeah, I think that is true. So what do you want to do if male is equals to true? I'm going to print, yeah, he is a male. So let me do this and let me save. So let me just break this one down so you can see what I'm doing. So now you can see that the instruction is running. So this is the condition here, which we are checking. And this is the variable. This is the instruction we want to run, we want to execute. So if the computer checks is male, now let me turn this to false. Now, and I run this. Now the computer is not going to do anything. The computer is going to just look at this code. Is male equals to true? I don't think so. Then it's not going to come in here and run anything inside here. It's just going to skip it like it did not see it. So that is conditions for you. So it's going to come inside here, check a little. It's going to check it. Is male equals to true? It finds out that male is not equals to true. It's going to skip this one here, this particular one here, and it's going to go to the next thing. Now we can attach something called else. So if you get to the market and there is rice, buy it. Else, come home. Now you have to come down here and extend another word called else. Now one thing you should know is that else does not have a condition. Else is do something if the initial condition is not met. If there is no rice, if there is rice, buy it. Else, buy beans. So there is no condition for else except there is no rice. So once I said if male is equals to true, this is what we're going to do. Else, what do we want to print? So I can just come here and just print. Here, he is not a male. So now, unlike before, whereby the computer was not able to do anything, it just had to skip the if. Now we have attached an else to it. So once we run this, this is not true. The computer is not going to run this. The computer is going to come down and run these. As you can see, yes, he is not a male. And that is conditions for you. Now, you might not get the grasp or the hands of it. It takes time. As I said, we're just going to the basics, which I'm going to be explaining two more important topic when it comes to integers and Boolean in the next section. So back here, we're going to be talking about comment. What are comments? Comments are like saying you don't want some codes to run like this. Now I come in here and I run this. You can see we have it running. But if I don't want this code to run, I can just come in and attach /. This is a comment and this is not going to run. So once I come in here, I run this, you wouldn't see anything on the screen. As you can see here, there is nothing on the screen and that's not going to run. So this is what we call a comment. So we use comments to, comment out codes and just disable some codes that you don't want to run. You can also use comment to write some kind of documentation in your code, like what I'm going to do now. So we're going to be talking about arithmetic operators. Don't mind my spellings. I'm trying to get my hands around spellings. So arithmetic operators. So what are arithmetic operators? Arithmetic operators work with numbers. Mean what kind of operations can a number perform? Now we're going to talk about all the arithmetic operators. We're talking about plus, the division, so the multiplication, the subtraction, the modulus. What again? So let's look into that and come to operators. We're looking at the basic operators that we're going to be having here. So as you can see, the multiplication, the addition. So let's just go down. Let's look for. Yeah, so add, subtract, multiply, divide, then we have the modulus. So those are the basic ones we're going to be looking at, so which I'm going to try now before we go into the next one. So let me just comment all of these because I don't want them to run. So add, divide, multiply, subtract, and modulus. So you know what, I'm going to start all from, so I'm going to print, and let me just create two numbers. Int num1 is equals to 5, int num2 is equals to 10. Always remember to put your semicolon, which means that is the end of a code. So I'm going to say int answer is equals to num1 plus num2. So I'm creating a variable to store the new answer, and I'm going to print in answer like this. So let me run this. You can see num1 plus num2 should give you 15. We have multiply, which is going to give you 50. We have minus, which is going to give you minus 5. Then we have divide, which can cause a little bit of issue. Now it says a value of type double can't be assigned. So why we're having error is because we said num1 divided by num2, and once num1 is dividing num2, we're supposed to have like 0.00 or 3 point something. Now that is another data type which is called double. So we can't use int here. So I just have to add double. So double is a different data type, and the computer, once integers are like whole numbers, and you can't store whole numbers inside integer. You can't store doubles inside whole numbers. So once I change data type to double, or you can change it to var, or you can change it to dynamic. So once I run this now, then we're going to have 0.5. So this type of data is called double. Now in programming, you need to learn how to read errors because it's very important you understand how errors are going to work. It's very, very important. So we have double, then we have another one called modulus. Now modulus is like doing the opposite of divide. Divide is going to give you the answer. So 5 divided by 2 will give you, 5 divided by 2 will give you 2 remainder 1. While modulus will give you the remainder as the answer. Divide will give you the answer. So let me show you. 5 divided by 2, we have 2.5, which is mean 2 remainder 1. That's what it's trying to say. Now, if you use modulus, which is the percentage sign, modulus will give you the remainder as the answer. So once I run it, we have 1 as the remainder. So it says can't assign. So 1 is integer, 1 has to. So let me just make it dynamic. But best practice says you use the inferred object. So as you can see, we have 1. So that is arithmetic operators. Other things we can have now is print num1. So we have other things. If you check in here, which if we come back to our operator, we have the plus plus operator and we have the minus minus. So once I come in here and I say num1 plus plus, I'm supposed to put in sorry, it has to put this guy in here. So I think I have to reload the page so that we can kind of input all of these. So let me run it now. So we have 6. Now plus plus means add 1. Plus plus means add 1. So if I use minus minus, you see we had 5 before, now we're supposed to get 4. It's going to subtract 1 from it. So these are arithmetic operators. They work for number basically. They work for numbers basically. Now the next thing I'm going to be talking about, before we're going to be jumping into functions in the next videos, we're going to be talking about logical operators, because I went brief into conditions, if and else, in a short while. So we're going to be talking about logical operators. So there's another thing called logical operators. So logical operators is how the computer thinks. What is the computer doing and how is it doing it? Now the first one we have is, I want to explain what this one means. Now this is called the assign. This is called the assign sign. The meaning of this is we've used it in various things where we say var name is equals to Victor. So the meaning of assign means take this thing, assign it to this variable. That is the assign sign, if you understand what I'm trying to say. So it's very important you know what that means. Then the second one we have is double equals to, which is equals to. Now this is like checking. Is this equals to this? So let me show you. So let's print 5 is equals to 5. Now this is like comparing. The computer has to give you an answer. Is 5 equals to 5? So once I run this, we're to get true. Let's cross our fingers and wait for it to run. Let me take all of this again, load these, and let me run this. Waiting. Yeah, so we have true, and that's because 5 is actually equals to 5. So there's another one called, so let me try. There's another one, let's try. Is 5 equals to 6? We're going to get false, because 5 is not equals to 6. There's another one called is not. This one, the exclamation mark and equals to. This is called is not equals to. So if I come in here and I change this, it does absolutely the opposite of equals to. So if I come in here and put is not equals to, so if you tell the computer 5 is not equals to 6, it will say yeah, 5 is not equals to 6. So once I run this, we'll get true. So you can see it's doing the opposite. Whatever equals to we say is true. Is not equals to we say is false. So as you can see, this is now true because 5 is not equals to 6. But whereby if I put in 5 is not equals to 5, this will give me false because 5 is equals to 5. How could you say 5 is not equals to 5? You see, you're going to get false. But if you come in here and we're going to use equals to now, we'll get true. So these are logical operators. Now the next one we'll be looking at is greater than. We have less than. We have greater than or equals to. We have less than or equals to. So let's try it. 5 is greater than 5. Is that true? That should be false because 5 is not greater than 5. But if I say 5 is greater than 3, that's going to be true. But if I come in here and say greater than or equals to 5, it means 5 can be greater than 5 or it can be equals to 5. So once I run this, I'm still going to get true. We have less than. 5 is less than 5. Which is false. If I even say 5 is less than 3, this will give you false because 5 is not less than 3. But if I come in here and say 5 is less than 10, of course, yes, 5 is less than 10, you're going to get true. So those are what's it called? Logical operators. There are more to it. There is and there is or. I'll be looking at that in later video. So if I come in here to go back to conditions again, I can say if 5 is greater than 3, then I want to print yes, 5 is greater. Don't forget to put your semicolon. So now the computer is going to check, is 5 actually greater than 3? Now if 5 is greater than 3, it's going to open this braces and it's going to run this instruction. Else, the computer is not going to do anything. So once I run this now, it's going to check, the computer is going to check, is 5 greater than 3? And yes, 5 is greater. But if I change this to 10 now, and I run it, nothing is going to show on the screen. And that's because 5 is not greater than 10. But if I attach an else now, I've kind of created a kind of an exception, a kind of what to do if 5 is not greater than 10. So is 5 greater than 10? No, and 5 is not greater than 10. So I'm going to print in here 5 is not greater than 10. So don't forget to put this. So once I run this now, you're going to see that 5 is not greater than 10. Once I make it like 3, which is 5 is greater, and you see, yes, 5 is kind of greater. So that is us just, trying to build around the conditions and the logical operators. We've done a lot of things when it comes to numbers. We've done a lot of things when it comes to Booleans, talking about true and false, which is ones and zero. So that's that for these basics of that. We're still going to be looking at more things into that, like in the next class on that basics. We'll be looking at functions. We'll be looking at methods in string. We'll be looking at list and classes, then also map in that. So you could read ahead, you could go through. So as I said, we'll be looking at the functions, we'll be looking at list, map, and we're going to be looking at classes in that. And please do not hesitate to go out, look for books, and watch videos on this Dart tutorials and programming language so that you can get the grasp of what's going on and what is happening. My name is Remain Python V. Do not forget to follow me on every social media, and don't also forget to follow Kim Plus and Nitida on their various social media handles. I'll be seeing you in the next video. Goodbye.